Early atomic theory began with Democritus in the 4th century BCE, proposing indivisible particles. John Dalton later developed the first scientific atomic theory in 1803, stating that elements are made of atoms and compounds form from these atoms. Dalton's atomic model suggested atoms were solid spheres that could not be created or destroyed. He established that atoms of the same element are identical, but different elements have different atomic weights. Compounds form from fixed ratios of these atoms. J.J. Thomson's 1897 cathode ray tube experiments led to the discovery of electrons. These were identified as negatively charged particles with a mass much smaller than a hydrogen atom, and they were identical regardless of the material used. Thomson proposed the plum pudding model in 1904. The atom was seen as a positive sphere with embedded electrons, similar to plums in a pudding. This was the first model to suggest that atoms were divisible. This image illustrates Thomson's plum pudding model, showing electrons embedded within a positively charged matrix. Millikan's oil drop experiment, conducted between 1909 and 1913, determined the charge of the electron. By using charged oil droplets in an electric field, he found the charge to be 1.602 by 10 to the power of negative 19 coulombs, proving all electrons have identical charge. In 1909, Rutherford conducted the gold foil experiment. Alpha particles were fired at gold foil. Most passed through, some deflected at large angles, and a few bounced straight back. Rutherford's findings showed that the atom is mostly empty space, with a dense, positive nucleus at the center. Electrons orbit this nucleus. This disproved Thomson's model and led to the planetary model of the atom. This chart summarizes the evolution of atomic theory, from Democritus's atomism to the modern quantum model developed by Schrödinger. The three subatomic particles are the electron, proton, and neutron. Protons and neutrons reside in the nucleus, while electrons orbit outside. They each have distinct properties regarding charge and mass. Protons are positively charged particles located in the nucleus. The number of protons defines the atomic number, and, thus, the element's identity. Protons have a mass number of 1. Neutrons, also located in the nucleus, have no charge. They are crucial for nuclear stability and can vary in number within an element. Like protons, neutrons have a mass number of 1. Electrons orbit the nucleus in an electron cloud and carry a negative charge. They have a very small mass and determine the chemical behavior and bonding of an element. Hydrogen has 3 common isotopes: protium with no neutrons, deuterium with 1 neutron, and tritium with 2 neutrons. Isotopes are atoms of the same element that have different numbers of neutrons. They share the same atomic number and chemical properties, but differ in mass number and physical properties. Isotope notation shows the mass number A at the top left and the atomic number Z at the bottom left, alongside the element symbol. For example, lithium isotopes share 3 protons but vary in neutrons, resulting in different mass numbers. Carbon also has common isotopes, such as carbon-12, carbon-13, and carbon-14. Carbon-12 and 13 are stable, while carbon-14 is radioactive, distinguished by their neutron counts. Uranium-238 and uranium-235 are important isotopes for nuclear energy. They differ in the number of neutrons and exhibit different fission properties. Isotopes have various applications, including medical imaging, cancer treatment, archaeological dating, and nuclear power. They are also widely used as research tools. In summary, modern atomic theory recognizes atoms are mostly empty space containing subatomic particles. The quantum mechanical model describes electrons residing in probability clouds, and elements can have different isotopes. Key contributions to atomic theory include Dalton's theory in 1803, Thomson's discovery of the electron in 1897, Millikan's experiment in 1909, Rutherford's nuclear model in 1911, and Bohr's quantum model in 1913.